Hello everyone, myself Nishan Jain. Today we are going to see some basic floats in MATLAB and the code of them. So first of all, let's proceed the code for the unit step function. So unit step function is simply it equals to 1 for x greater than equal to 0 and 0 for them. So I have written the code for it, simply subfloats. First of all, we have written this code for the continuous, and further this is for the discrete. Okay, so second one function we go to is the rectangular pulse function. So we already have rectangular pulse function defined in MATLAB, already exists there. So I have taken fs to be this. I have taken fs to making the step of the time, that is -3 to 3, and using the rectangular pulse function here. So subfloat, and this I have written by the rectangular pulse function, and I have taken here 0.5 to see the graph properly, because I am in the second part I am using the discrete, so that's why. Now move to next one is for signum function. Signum function, as we know that it is 0 for x equals to 0, and for x less than 0 it is -1, and in x greater than 0 it equals to 1. We have already here also we have defined sine function, so I have directly used it. And the next move to another one. So let work one, because I have not shown anyone right now. A2 Q1, so I have named it. So let's see how the graph is. So like this the graph will look. Okay, so let's move to another D part. So this is the ramp function. Ramp function we already defined the unit step function earlier, so it's simply t times unit function. So let's run it. So A2 Q1 D, how it's look, it will look like this. This is continuous, and this is discrete function. So another next one is sinusoidal function. I have used the sinusoid as sin x and simply plot it. Already we have done in earlier video this. So let's run it. Into Q1 D. Okay, so it will look like this, as you can see in the screen. So next one our function is real valued exponential function. So I have taken e raised to power x, I have taken a is equals to 1, b is equals to -1. So I have taken e raised to power x and e raised to power -x. This condition is written for the e raised to power x, that is y1 continuous, and this is for y1 discrete, this is for y2 continuous, and this is for y2 discrete. Let's run it, and how it comes to be, let's see Q1. So it's coming out to be like this: increasing discrete, decreasing discrete. Okay, so let's move to another one, that is G. So this is a casual exponential function. It is nothing that any exponential function is casual exponential function, written code similarly as like similar one, and answer will be same also. So next move to another part, that is impulse function. Impulse function is at x equals to 0 it is 1, and for other it is 0. So I have written the condition. You can see my cursor, there is a condition for it. So let's run it. Q1. So this is coming out to be like this. Okay, so let's move to question 2, part 1 question 2. So what is that? So this is the periodic sawtooth function with time period t is equals to 3 seconds. As we know that the sawtooth function we have defined earlier, it is predefined function. Sawtooth comes down to be, so I am taking fs 3 seconds is the time period given, so I have taken t is equals to this and 3 seconds, and this is for the stepping I have done. And sawtooth is a predefined function, already exists here in MATLAB, so I have directly used it. This is I have written for the continuous, and this is for I have written for the discrete. Why I have taken this again in, because I have done stepping smaller, so that's why I have looked this. So how it looks, let's see, it comes out to be like this, as I seen earlier. So the function comes out to be like this. Okay, so next move to another one, that is periodic pulse wave. I am generating a periodic pulse waveform with time period t, and its speed is equal to t/4. So I have made the conditions. I have taken t is this, and made the conditions is if t is equals to I, then equals to 0, and t greater than equal to I, it is, and less than equal to I plus 1/4, it is 0, and t is greater than equal to I plus 1/4, and t less than 0.5 equals to 1, and similarly this condition 0 and again. So it makes like a square waveform with time period t and its width to be t/4. Let's run it, see is it coming or not. So I have not written properly. Q2 T underscore repeat. So you can see this is coming. Why it's coming discrete to be like this? Because I am not done stepping in this case. We can also do in this case also for to look clear. Then the C part is for that periodic square waveform, and I have made the conditions t from this to this, and I have made these conditions for the square waveform. It is +1 for t greater than equal to I and t less than I plus 0.5 equals to 1, and it is greater than equal to I plus 0.5 and t less than I less than equal to I plus 1 and equals to -1, and this is for continuous and discrete, as you know that. Let's run it and see into Q2 3. Okay, and same I have not done stepping properly for discrete functions, so it's looking like this. And move to D part. D part is what is this? D part is simply the periodic triangular waveform. So periodic triangular waveform, it is similar as like that. So I have written the conditions for periodic triangular waveform is t is equals to I then equals to 0, t greater than equal to I and I plus 1/4. So it equals to x, and x varies from 0 to 0.25 with a step of this, as like this you go this, and similarly further this. By this whole conditions I am making as it in a form of a triangle. So let's run and see how the coming out to be to D. So see this, it is a triangular waveform. It's coming some form of triangles, and this is for discrete function also. So let's move to another part, that is periodic sinusoidal waveform with time period equals to 1 milliseconds. So I have written the code for this, but here particularly mentions the time period is equals to 1 milliseconds. So as you know that the frequency omega is equals to 2 pi into time period. So I have written this 2 pi into time period into t. So I like this, I got the graph. So let's need Q2 Q2 t. It's coming to be okay. This line is coming. Now let's move to the third part of the question. First question, third part. So here nothing we have to do, simply we have given that 3 sinusoidal waves with the amplitude 1 and frequency 100, second one amplitude 0.75 and frequency 250, and third one amplitude 0.5 and frequency 500, and we simply have to add them, and I have written the code for this. Let's run it and see if it to Q3. Okay, how it is coming to be. It's coming out to be like this graph. Okay, as we see like this. Then next one is nothing in the fourth part. Fourth part is nothing, we have simply multiplied here the two waveforms, sinusoidal waveforms with amplitude this and frequency 0.15, here amplitude 0.5 and frequency is equals to 100, and I have done all this earlier also. So a simple code is written A2Q4. Let's run it and see how it's coming out to be. It's coming out to be like this graph, very continuous and just discrete. Okay, let's move to the let's make all these graphs and plots into a form of a GUI. So where we can generate all these things. So for GUI I have generated a GUI like this. So I have mentioned here which type of function I want to function plot I want to see, and similarly there may be some conditions for that participant. So one by one I have put all the here in all the push keys I have written the codes of proper codes of exactly that function in that push key. So if I push that, then it will plot that graph. Okay, so let's see the graph that not be much than like this. So there are many push function keys. I think there are total 13 push function keys I have written. So like this, in push question 13 I have written its code. So I have pushed key 13, then it will load that. So let's see how it works. So this is the final GUI is looking as. So let's see. I want to build a RAM function. So I click on the RAM function, and the output is coming to be this. See, this is the plot of the RAM function. Now I look one another in which I have to give input. So here in periodic sinusoidal waveform, it needs the input. So I click on it, and it is asking that enter the time period. That the time period should be less than 0.01. So let's say me input 0.03. Okay, and run it. See, this will be the form of a graph. Okay, like this I can run all the GUIs, and I have interlinked my code with the template. See, this is my main template of the GUI. Okay, so thank you for watching the video.